Hello everyone, good morning. On this short film what I'm going to try to do is show you how to use the Multsim circuit calculation tool. Multsim is a very powerful circuit simulator that you can use to simulate all sorts of analog circuits. And in this film I'm going to try to show you how to simulate a simple low-pass filter, and then hopefully you can then use it as much as you like. So this is the actual circuit that I'm going to try and show you how to simulate. It's got relatively simple. It's just got a resistor and a capacitor, an oscilloscope to record the outputs, and a voltage source. So the first, I'm going to try and show you how to draw this from scratch though, so that you can see how to do it yourself. So I've got another tab here. I'm going to start placing some components to draw the circuit that we're interested in. So I go up here to the place command, place component, and I'm then going to look for the different components. Now the first one that I'm going to look for, if you can see here on this group, if I click on all groups, it gives me a very wide range of components that I can put into the circuit. This is a huge list of all sorts of different standard components, but I'm going to start just by putting some basic things in. So I can go to sources, and if I go to signal voltage source, I can see also a few different types here. I just want the first one, which is an AC voltage, which you can see over here. So I'm going to click that and put that as my first thing in my circuit. It then reopens the window to see whether I want to put something else, and in fact I'm going to need to put in a ground, because all these circuit simulators require you to define the ground level. So I'm going to stick a ground, and I'm going to put that sort of about here, because it's usually best to have it at the bottom of the circuit. Then I need to find some of my other basic components. So I go to the basic component setting, and I can see resistors, for example. Now I'm going to put the 4.7k resistor in that is selected there. I'll stick that sort of up here on the top of the circuit, and then I'm going to look for a capacitor. I'm going to sit the 47 nanofarad capacitor in. I'm going to put that around about here in the circuit. And that's all I need for now, so I'm going to close that window down. Now it's better if I rotate the capacitor, so I can right click on it and rotate it by 90 degrees, and that's the value there. And then if I want to connect the components up together, then I simply need to put my cursor on, and it will activate the wire command, and I can draw down the different wires. So I've connected that one there up. I'm going to connect that up there. Oops, that didn't quite take. Sometimes that happens. Just need to go back and make sure that it does. I can bring that one down here, along, and then up again. Oops. If I want to bend the corner like that, then I just click it once and it will go up. And then I just need to connect my ground up to this baseline here. So that's my basic circuit, and then if I want to insert the oscilloscope so that I can measure, I need to go to simulate and instruments, and a whole range of different instruments come up. I'm just going to use the basic oscilloscope, and I'll stick that over here. Now the oscilloscope, I'm going to measure the output voltage, and if you remember the circuit from your notes in class, then actually the circuit, the output point is this point up here. I'm just going to try and get the wire to look reasonably logical, so that's the point there. So my output for the filter is between the resistor and the capacitor, and then I just need to connect this other line here on the oscilloscope round to the ground level on the base down there. So that's my circuit now, and I can see here that the voltage comes up as a default is 1 volt peak to peak, 1 kilohertz for example. If I want to change that, I just double click on it and I can change the values here. So I'm going to keep those for now, and then I'm going to press run. So I just press run, and then if I double click on the oscilloscope, it comes up and you can see it's happening here. Now, like all oscilloscopes, I need to do things like control the triggering. So let's try the single trigger. That can be a useful thing. And I'm going to try now you can see that it's being triggered off that single voltage. It's now become a stable waveform. but the scale is a little bit large, so I'm going to enlarge it a bit, and then I can also play with the time base to spread out the thing here. So I can see that my peak-to-peak value is going through the circuit correctly. Now with a filter, obviously what I need to do is do a sweep of the frequency, so I can see how the circuit changes with frequency, and that I can do by stopping first the simulation, clicking this button here, and it will bring up the different ways I can do the simulation analysis. So this is the analysis and simulation tool. I can actually also get that from up here on the simulate button as well. I'm going to go for an AC sweep, and I'm going to ask it to stop. This is the start frequency and the end frequency. 10 gigahertz is a bit high, so let's put maybe 100 megahertz instead, and then I'm going to save that. And now if I click run, it'll do that sweep. Oh, I've forgotten to add some output variables, so I needed to go back up here and I needed to add some output variables. And if you look on the circuit, I've got different voltages. That's the voltage. I'm going to add that from the supply. I'm going to add a couple of these voltages that are shown. I now save. I can now run, and this now brings up what's called the grapher tool, and that generates on the screen the graphs, and it's a graph of the magnitude and of the phase. Now you can see that the V1 is just fixed. That's the power supply value here, and what's changing is the green line, which is the value of the output point. And if I want to see these in different ways, I can. This is on a logarithmic scale at the moment. If I double click on it, I can change it to a linear scale, for example, and that then shows you a little bit more clearly that the voltage coming out at the output point is going down as the frequency rises. So below 100 Hertz, the filter passes everything. It starts to decrease. By the time I get to 1 kilohertz, it's a fair way down already, and by the time I get to 10 kilohertz, hardly anything is getting through the filter. So this is a low pass filter, just as I'd expect. And here I see the phase of the signal as well, changing in the same way as the output value there. So this Multsim circuit simulator is a very powerful tool for calculating these simple circuits, and it's an ideal tool for use really throughout all of your analog electronics work, both in this module and through the rest. And hopefully you can try and do this yourself, and then you'll have a good feel for the basics of the simulator as we go through the course and build up your skills that you can use in all sorts of other modules. I hope you found that useful. If you didn't, play it again, and hopefully you can see all the different things that I've done, and that will give you a good indication of how to use it.